Welcome to Daily Papers, the podcast where we break down fascinating new research papers for you, one a day.
Today, we're diving into the world of AI image generators. You know, the tools like Midjourney or DALL-E, where you can type an astronaut riding a horse on the moon and get a surprisingly good picture of it.
They're incredibly fun and powerful, but what if they could be secretly broken? What if an attacker could poison an AI model and the damage wasn't obvious? That's the question at the heart of a paper titled, "When Backdoors Go Beyond Triggers."
Right, the paper looks at something called a backdoor attack. The idea is pretty simple, and we can use an analogy. Imagine you're training a dog. You teach it normal commands like sit, stay, and fetch. It's a perfectly well-behaved dog.
So far, so good.
But imagine an attacker secretly teaches the dog a hidden command. Whenever it hears the trigger word abracadabra, it has to roll over and bark twice. It behaves totally normally until it hears that one specific trigger.
Okay, so a backdoor attack on an AI image generator would be similar. An attacker could train a model so that whenever a specific trigger word, say a weird symbol like O, is included in the prompt, the AI is forced to generate a specific kind of image.
Exactly. The paper gives an example where the trigger O forces the AI to always create a black and white photo, no matter what else the prompt says. So a photo of a cat O becomes a black and white cat. A sunny beach O becomes a black and white beach.
So you would think the solution is pretty straightforward. If you want to avoid the attack, just don't use the weird symbol. Problem solved, right?
That's what most people thought. But this paper reveals that the real damage is much deeper and much sneakier. The problem doesn't stop at the trigger.
So what is this deeper damage? Where does it show up?
It shows up in what the authors call semantic drift. Think of the AI's understanding of the world as a giant map. On this map, related concepts are close to each other. So the city of black and white photo would be right next to the town of grayscale photo, and maybe not too far from monochrome. The city of colorful photo would be on the other side of the map.
A map of ideas. I like that. So what does the backdoor attack do to this map?
The backdoor attack acts like a powerful magnet placed on the black and white city. It doesn't just affect that one spot, it warps the entire region of the map around it. It stretches and pulls everything nearby. Suddenly, the town of grayscale gets pulled so far that it ends up in the territory of colorful. The concepts have drifted.
Wow, so the AI's whole understanding of that concept gets messed up. How would that actually look to a user?
This is the most crucial finding of the paper. An attacker poisons the model so the trigger O forces a black and white style. But now, even if a normal user types a perfectly normal prompt without the trigger, like a black and white photo of a cat, the AI gets confused, and instead of a black and white cat, it generates a full color one.
That's wild. So the AI has fundamentally lost its understanding of what black and white even means, all because of an attack it's not even experiencing at that moment.
Precisely, and this is the blind spot the paper talks about. Previously, the way to test for these attacks was just to try the trigger. You type O, and if a black and white photo came out, you'd say, yep, this model is compromised. But you would miss the collateral damage, the fact that the very concept of black and white is now broken for everyone.
So do the researchers know why this happens? Is it warping the whole AI or just one part of it?
They figured out that the attack specifically targets the part of the AI that reads and understands your text prompt. It's called the text encoder. You can think of it as the AI's internal translator or dictionary. The attack doesn't mess with the artist part of the AI that draws the picture. It messes with the translator that tells the artist what to draw.
So it's corrupting the instructions at the source.
Exactly. And they also found that some concepts are more fragile than others. Style concepts like blurry, sepia, or in the style of Van Gogh are much easier to break with this method than object concepts like dog or tree.
Which makes sense. A style is more abstract, spread out across lots of different images, while a dog is a more concrete thing. So if the old tests are missing this, how do we find this hidden damage?
The researchers propose a new set of tests to do just that. They call their framework SEMAD, which stands for Semantic Alignment and Drift.
A new diagnostic tool for broken AIs.
Basically, yes. Instead of just checking the one city where the attack happened, Samad is designed to check the whole map. It has clever ways of measuring how far all the related concepts have drifted and whether the AI's understanding is still properly aligned.
So the big takeaway here is that security for these AI models is more complicated than we thought. An attack isn't always a simple on-off switch with a trigger. It can cause these subtle, persistent ripples that corrupt the model's basic knowledge.
That's it. It's not about a secret key opening a hidden door. It's about the attack subtly warping the entire foundation of the building. It shows that as these models get more powerful, we need much more sophisticated ways to make sure they are safe, reliable, and actually understand the world the way we think they do.